so this is the solution for activity 1, which is to implement a Shapiro-Wilk test. That's a hypothesis test for the normality of a distribution. So first off, we need to import some packages to be able to use the tools we need to accomplish this. So the first package is pandas, import pandas, and then the second package is scipy.stats, and the last package is numpy. So once you have those packages being imported up on top, you also need to make sure you have def main and if name equals main blocks. This was discussed in the user interface video of Visual Studio. And a couple of these steps are identical to the CSV video walkthrough. So I'm just going to briefly go over them. Here we import the data frame from this CSV file, and then in this step we store a list of the values only in the income column. Alright, so from here we need a way to determine which values we need to remove in order for this test to work. And so this test only works if none of the values are null or not a number. Alright, so next we have a for loop. And the for loop is going to iterate through every data point contained in the array, in the list. And it's going to determine if the data point is a number or if it is null or not a number. And then if it is a number, it's going to add it to this new array variable. And so the new array is going to be what we're using for the test down below. So we want that to be only numbers and no null values. So the syntax is a little bit different than a standard for loop. Basically, the reason is because we need to get the index as well as the value from each cell in the array. And so that's done using the enumerate function. So you want to the overall syntax is for index variable, so I put I, comma, and then the variable to which the value is going to be stored, so I put val, in, enumerate, parentheses, and then the array you want to iterate over. And so I put the array that has the list of, and then in parentheses, the list you want to iterate over. Alright, and so for each value, each data point in the list, it's going to execute this statement. And so this is an if statement, and if this statement is true, then it will execute this code and add the value to the list. So it basically checks the corresponding location in the not a number array. And this is, again, a true or false value. True if the value is not a number, false if the value is a number. So we want this to execute only if the value is a number. And so if this value is false, we want to execute the code because that means that the value is a number. So in that case, we need to put the not qualifier before it. And so that means if this statement isn't true, then execute this statement. So once that completes, it will have populated the new array list. And so the next line of code is actually running the test. So when you have two variables separated by a comma like this, it means that this function is outputting two variables. It has two returns. And so the function we want to use is from the scipy stats module. So we put scipy.stats and then .shapiro, which is the function, and then parentheses, and then we want to put in the input new array that we just created. And then we're storing to the variables stat, which will be the test statistic, and p-val, which will be the p-value. And so the final block of code is an if statement. It compares the p-value to alpha of 0.05. If it's less, it rejects the null hypothesis. The final block of code is an if statement, and so it compares the p-value to 0.05. So if p-value is less than 0.05, then this code executes. And that is something that prints in the console that the null hypothesis was rejected. And so we want to also do something when this statement is not true. So when the p-value is greater than 0.05, and we do that by putting an else after, in line with the if, but after the block of code that you want to execute if this statement is true. So an else here, colon, and then in the same way that you have indented below whatever code that you want to execute if this statement is false. So I have it printing that the null hypothesis is not rejected. All right, so I basically just added this one line to print the p-value, but when you run this code, let me go ahead and clear the terminal. But if you run this code, it will report back the p-value, which is insanely small, as well as the status of the rejection of the null hypothesis. And that should be it for activity 1.